Good afternoon, class. We are looking at chapter 8. Further applications of trigonometric functions. Here's section 8.2, the law of cosines. So we looked at the law of sines and now the law of cosines. The objectives are to solve SAS triangles. S stands for side, A stands for the angle, side, angle, side. And also to solve SSS, all sides, side angles, and solve applied problems. Properties of trigonometric functions, everybody remembers those fundamental identities, such as Pythagorean identities, quotient identities, reciprocal identities. Trigonometric functions are periodic with a period of 2 pi, tangent and cotangent, period of pi. They are odd functions, except cosine and therefore secant. In a right triangle, a squared plus b squared equals c squared, and a plus b, they add up to 90 degrees. And sum and difference formulas, such as sine of alpha plus beta is sine alpha cosine beta plus cosine alpha sine beta. And we can use this to get to double angles. For example, if we change the beta here, we get sine of 2 alpha, which is 2 sine alpha cosine alpha, the rest of them. From here, we can solve for sine squared of alpha, cut the alpha in half to get to the half angle formulas. Here, cosine squared alpha, and then cut it in half. And the ratio of sine to cosine gives you tangent. And then if you want to get to sine of alpha over 2 or any other one, you take the root plus minus, and you decide positive or negative based on the quadrant. And here's a short summary of the product to sum and sum to product formulas. So when we discuss the right triangle, okay, in this case, a squared plus b squared equals c squared, a plus b equals 90 degrees, and sine b, the opposite is b, and the adjacent is a, and the hypotenuse is c, so b over c by definition. A cosine would be a over c, and the rest of them follow. Angle of elevation, quickly reminding you, is the angle formed by the line of sight and the horizontal plane for an object above the horizontal. So here's the horizontal side. If you look up, creates an angle of elevation. If you look down, creates an angle of depression. As far as the bearings is concerned, there are 2 methods. Number 1, the direction or bearing of a point is the number of degrees in the angle measured in a clockwise direction from the north vertical line to the line joining the center of the compass with the point. And number 2, direction or bearing of a point O to a point P equals the acute angle between the ray OP and the vertical line through O, the north-south. Meaning, in the first method, you just look at the north and go clockwise. For example, this one, you see 65 degrees. That's all you mentioned, 65 degrees. Whereas for Q, it covers 300 degrees. So you go clockwise. But in the second method, for example, if you want P1, you start with the north because it's closest to north. And then 30 degrees, the right side is east. Whereas this one, P sub 4, it's closer to S, so south, 20 degrees east. And the rest of it. The law of sines, or sine law, says sine of A over A equals sine of B over B equals sine of C over C. And we have 1, 2, 3, 4 cases here. ASA, angle side angle, SAA side angles angle. One side and 2 angles results in 1 unique solution and 1 unique triangle. SSA, side angle, 2 sides and angle opposite one of them could result in several different situations and solutions to occur. Consequently, SSA is referred to as the ambiguous case. So what happens? This angle is acute, A equals to H. We have one triangle. In fact, it's a right triangle. If this is acute and A is less than B, A is larger than B and larger than H. In other words, H is less than both sides. Then again, we have one unique solution. If A is obtuse means between 90 and 180 degrees, right? And A is larger than B, then there is a unique solution, a unique triangle. If A is acute, but A is less than H, then nothing works out. Or if A is obtuse and A is less than or equal to B, simply because the larger the angle, the larger the side opposite that, and it doesn't work here, no triangle exists. However, if this is an acute angle, okay, and H is less than A and less than B, then we have two possibilities, this little one here and the entire triangle. That gives us two different triangles. I hope everybody is following that. It's very straightforward, everybody. SAS, side angle side. Two sides and the included angle result in one unique solution and one unique triangle. SSS, we have all sides. Three sides result in one unique solution and one unique triangle as long as one side is smaller than the sum of the other two sides, and that requires the cosine law. This is important to understand. Two sides, when you look at one side, has to be less than the sum of the other two sides. Otherwise, it can't create a triangle. So what is the law of cosine? Cosine law says a squared equals b squared plus c squared minus 2bc cosine a. We will look at the proof in a moment. Case 3, SAS. Two sides and the included angle result in one unique solution and one unique triangle. Case number 4, SSS. All sides, three sides result in one unique solution and one unique triangle as long as one side is smaller than the sum of the other two sides. It requires cosine law. Now, theorem SSS has no solution if A is larger than or equal to B plus C, if one side is larger than or equal to the sum of the other two sides. Here's the formulas for various sides for A squared. We have it if you want it for B squared. In short, notice, if you want A squared, so this has to be the other two B squared plus C squared. This has to be the other two minus 2BC cosine of this angle. So this one, you want B squared, A squared plus C squared minus 2AC cosine B, and so on. Now, if we move this to the left and A squared to the right as follows, this moves and this moves, then we can solve for cosine A, which is B squared plus C squared minus A squared over 2BC. That's the result of that. Also, note the following. This is important. The law of cosine generalizes the Pythagorean theorem, which holds only for right triangle. Remember, Pythagorean theorem says A squared equals, we normally use A and B, A squared plus B squared equals C squared. Look at this one. If you change this to a 90-degree or pi over 2, cosine is 0, so that gives you Pythagorean theorem. That's the idea. So this is a generalized form that works for any angle. Let's quickly look at the proof. All right, so we have this triangle ABC, and understand, opposite capital A is lowercase a side, opposite B, those are the vertices, lowercase b, and this is lowercase c, this is c, and we're going to call this D. And so in the triangle ADC, in this one, in this one, this angle, cosine A is the adjacent, which we call it x. So this distance is x, everybody. This is c minus x, this is c, okay? This whole AB is c. So it's x over the hypotenuse b, because x squared plus h squared equals b squared, and cosine A is x over b, x becomes b cosine A. One more time. So this is x, AB is c, so this portion is c minus x. In this triangle, Pythagorean theorem says x squared and h squared, they add up to b squared. And cosine A is the adjacent, which is x over the hypotenuse b. Cross product gives us x. Now let's go to BDC, the other triangle. Let me use a different color here. Let me shade it with a different color. Now we are looking at the green one. And Pythagorean theorem says this one plus this one squared is this one. So this one and this one, right? So what is this? C minus x squared. What is this? H squared. What is this? A squared. So C minus x squared plus h squared is a squared. Let's raise this to the power of 2, and everybody remembers that a minus b squared is a squared minus 2ab plus b squared. So this is c squared minus 2cx plus x squared plus h squared. So you just raise this to power. Notice x squared plus h squared is b squared. And notice x, we can say b cosine A. So we are going to change the x to b cosine A. And we're going to replace the x squared plus h squared with b squared. Clear? So a squared is b squared plus c squared minus 2bc cosine A. That's the proof. You can do the same thing for the rest of them by just dropping drop the perpendicular, the altitude here or here or here, and you can do the rest of it. Okay, so that's a proof of the law of cosines or cosine law. Using cosine law to solve SAS, solve the triangle where C is 60 degrees, A is 2, B is 3. Normally, if it's not given to you, you make it up, everybody. All right. So let's see what is given and what is missing. So we are dealing with this angle being 60 degrees. This is 2, this is 3. So we can find this one, using this formula. So c squared is a squared plus b squared minus 2ab cosine c. Just plug in. So this is a 2 squared plus 3 squared minus 2 times 2 times 3 times cosine of 60. I mean, cosine of 60 happened to be a common arc, and we know it's 1/2. But anyways, so it happened to be 1/2, okay? And this is 4, this is 9. We get 7, and c is square root of 7. So again, normally this is not, and this is, let me just, normally this is not a common arc, so we may not know it, okay? So you use a calculator, but that's the concept. All right, so we have this one as square root of 7. Since two angles are missing, we have to use this formula to find cosine A, which is b squared plus c squared minus a squared over 2bc. And so just plug in, you have everything. B squared is 3 squared, c squared, the answer is 7. We already have the c squared here. C squared is 7. Minus a squared, which is 4, 2 times b, which is 3, times c, which is square root of 7. Just plug in. And so the numerator becomes 9 and 7. 16 minus 4 is 12. This is 6 over square root of 7. These two cancel each other. We get 2. And 2 over square root of 7, you can rationalize it. You get 2 square root of 7 over 7. But you have to put it into a calculator. So if you don't do it, that's fine, because A is cosine inverse of this. And that's 40.9 degrees. And you replace this with 40.9 degrees. And all you have to do, add these two, subtract it from 180 to get B. $79.1 degrees. Put it there and you're done. All right, let's move on to the next example, everybody. A is 4, B is 3, C is 6. We have all sides. Let me just remind you. So this is obviously capital A, C, capital B. So opposite the vertex. So opposite A, this is lowercase a, lowercase c, lowercase b. That's how we name him, okay? So we use the same vertex, but we go with the lowercase, meaning the side. And so we want to solve this. That means we need to find the angles, and you have to go with this formula. For example, cosine A is b squared plus c squared minus a squared over 2bc. Just plug it. So the numerator is 29. 2 times 3, 6 times 6, 36. So A is cosine inverse of this number, which requires a calculator to find the answer. That gives you 36.3 degrees using a calculator. So if A is 36.3 degrees, put it there. Now let's move on to another one. So if I want cosine of, let's say, B, then basically this changes to A squared plus c squared minus b squared. You interchange these two in essence over, okay, over 2ac. Let's see what we have here. 16, 36 minus 9. So we get 52 minus 9, which is 43. The bottom is 2 times 4, 8 times 6, 48. So B is cosine inverse of this number. So angle B is cosine inverse of this number. Putting it into a calculator, 26.4 degrees. So we put 26.4 degrees here. And so what about C? We're not going to go this route. We're just going to say add these two, subtract it from 180. Okay. So 180 minus this and minus this gives us C, which is 117.3 degrees. It's pretty straightforward. I hope everybody's comfortable with that. I'm going to look at a couple of examples of applications. So this is 117.3 degrees. And let's look at this example. We are looking at applications, solve applied problems. A boat leaves Naples for Key West, 150 miles away at 15 miles per hour. So we are going from here to here, 150 miles, and we are doing 15 miles per hour. It encounters heavy crosswinds and strong current. The crew finds after 4 hours, 4 times 15, 60 miles, that the sailboat is off course by 20 degrees. So 4 hours later, they have covered 4 times 15, 16 miles, and they are off by 20 degrees. How far is the sailboat from the Key West at this point? That means side X, and there are other parts that we're going to look at. So X is a question mark for us. So we have this side as 150 degrees. We have this side as 150 miles, my apologies. We have this side as 60 miles. We have this angle at 20 degrees. And we can use a squared equals b squared plus c squared minus 2bc cosine a. And we are going to plug in. So x squared is this squared plus this squared. So 150 squared plus 60 squared minus 2 times the product of these two numbers, cosine of 20 degrees. Using the cosine law, we find this side. I hope everybody's clear on that. Now, of course, you got to put this into a calculator. So I'm assuming you put this into a calculator. You get this number, and x is the square root of that. 95.8, about 96 miles. Again, as far as the number of decimals, normally we carry a lot. But if it's an approximation in the first place, it's just pay attention to the number of decimals they ask you. So that's very straightforward. We had two sides, they included angle. We used the cosine law, and we're done with that part. So this is about 95.8 miles or 96 miles. The second part says, through what angle should the sailboat turn to correct its course? Its course. That's what we are doing, fixing things up. Well, it's going this way, and it wants to go this way, so it has to turn this much. We're going to call it theta. How do we find theta? Well, if we find A, 180 minus A would be theta. So the answer is theta, and theta is 180 minus A. So I hope everybody's clear. All we have to do, find A. And in this triangle, we can find A because we got two sides, the angle over there. So it's easy to find it. Because we have all three sides, everybody, right? We have this side, and we found this one to be 95.8, 96, whatever. So we are going to use cosine law. And we want to find this angle, so this one squared, 150 squared is this side squared plus this side squared, 95.8 squared plus 60 squared, minus 2 times the product of these two numbers, 95.8 and 60, and cosine A. So in order to find this one, we use 150 squared on one side, the rest of them on the other. So what happens? We plug in everybody. We use a calculator. We end up with 9684 being minus 11,520 cosine A. So we square this one, we square this one, we square this one. We move this one, we subtracted, we move this one, we subtracted, and this is the right-hand side. Okay, just to give you an idea. We divide by this number, negative 11,520 to get cosine A. And now A is cosine inverse of this number, everybody. Cosine inverse of this number, And that gives us 147.2 degrees. Remember, when cosine is negative as far as the inverse, since cosine goes from 0 to pi, it will be somewhere between pi over 2 and 2 pi over 2 in the second quadrant. So we found A to be 147.2 degrees, and so we almost have theta. Theta is 180 minus 147.2 minus A, which results in 32.8 degrees. So we got the angle 32.8 degrees, everybody. How much time has been added to the trip because of this? Assume that the speed remains at 15 miles per hour. So we are supposed to go from point A to point B, from Naples to Key West, a distance of 150 miles. However, we are gone 60 miles and we need to go 95.8, about 96 miles. So the sum of these two minus 150 is the extra added distance. 60 plus 96 minus 150, that gives us 6 miles more that we are covering. So time is distance over r, d over r, because I hope everybody remembers the elementary algebra, d equals rt, right? Again, distance is the average speed times the time it takes, average speed. And so with that being the case, d, the distance is 6 miles over r, and we are doing 15 miles per hour. That's our speed. That's our rate. 6 divided by 15 hours, which makes it 0.4 hours. You multiply it by 60, gives you 24 minutes. So just to class this one, if you multiply by 60, gives us the number of minutes. Okay, everybody knows that. Okay, here's the next application problem. An airplane flies due north from Fort Myers to Sarasota. So we are going this way. A distance of 150 miles, and then turns through an angle of 50 degrees. So we turn 50 degrees to Orlando, a distance of 100 miles. How far is it directly from Fort Myers to Orlando? That's what we are interested in. So we are interested in calculating this distance. We're going to call it A. That's what's missing. Well, what is this angle? We need to find it. We know this is 50, everybody. What should A be? Don't they add up to 180 degrees? So A is 180 minus 50 degrees. So the angle A is 130 degrees. And now we use A squared plus B squared plus C squared minus 2bc cosine. So we're going to use that. So A squared, which is missing, equals B squared plus C squared. So 150 squared plus 100 squared minus 2 times 150 times 100 times the cosine of the included angle for those two, cosine of 130. Then you put it into a calculator class, okay? That results in A squared being this number, 51,783.554. And A is the square root of that. So A is 227.56 miles. So if we go directly, we cover 227.56 miles. Otherwise, it's 150 and 100, add up to 250 miles. What bearing should the pilot use to fly directly from Fort Myers to Orlando? Well, we need this angle. And when we find it, we say north, this angle B, which we don't have yet, right side is east, right? We are going in this direction, right? So north, B degrees east, that's the direction. So all you have to do, find B. And to find B, we can use the cosine law or even the sine law. I'm going to actually go over both of them because this section is cosine law. First, let's go over the cosine law. So this B this angle B is between this one 150 and this one 227.56 miles. So we are going to say the opposite. That's the 100 squared equals 150 squared plus 227.56 quantity squared minus 2 times this one times 150 times 227.56 times cosine of the included angle, cosine B. You go through the process, you find cosine B, everybody. I want to show you the second. I'm going to leave it for you to find. I'll give you the answer, but all you have to do, plug it. The second method is the sine law. Okay. Sine of a B over 100 is sine of A, sine of 130 degrees over 227.56. So if you do the cross product, sine B becomes 100 sine of 130 over 227.56. You put the sine inverse, you come up with the answer. And in this case, cosine B is 0.9415. If you go this route, you go with sine B. Now B is the cosine inverse of this number, and it's 19.7 degrees. Okay, everybody. So B is the cosine inverse of this angle, this number. So I hope everybody is okay with that. Very straightforward, everybody. And so therefore, the final answer is north, 19.7 degrees east. Very straightforward, everybody. So we are going to move on. Flying from Chicago to Louisville, 330 miles, a pilot carelessly took a course that was 10 degrees in air. So we're going to go this way, and we're going to cover 330 miles, and we go this way by mistake, which has a 10 degree in air. Okay. If the aircraft maintains an average of 220 miles per hour, and if the error is discovered after 15 minutes, through what angle should the pilot turn to head towards Louisville? So 10 degrees, we are going the wrong way at some point later, meaning 15 minutes later, we notice that we have to turn through this angle to go to the right place. And so B is this angle, and what we need is 180 minus B. Okay, so let me just do this. So B is this angle, everybody. After we find it, then the angle we are looking for, because the sum of these two is 180, subtracted from 180. That's all there is to it. So let's find angle B, and then 180 minus B is the answer. Well, D equals RT, this distance is C, let's say, and we have been going for how long? 15 minutes. And what is our speed? 220. So let's see what we covered here. How much distance? So D equals RT, the rate is 220, and the time is 15 over 60. Class, 15 over 60. I want to explain this one more time. First of all, this is the rate. Now 15 minutes, but the units are 220 miles per hour. So you have to change this to the hour. When I divide by 60, 15 minutes becomes 1/4 of an hour. So by this, I'm changing it to hours. Okay, so, and we get 55 miles. So C is 55 miles. We have this distance now. So we have this one, we have this one, we have the included angle. We can find the last side, namely A, and then we have all sides we can find, and we have one angle. Even if we didn't, we could find all angles. So A squared equals B squared. So A, we call this A. A squared is B squared plus C squared minus 2BC cosine A. So that means this side, 330 squared, plus this side, 55 quantity squared, minus 2 times the product of these two numbers, 330 and 55, cosine of the included angle, 10 degrees. And you just put it into a calculator, you take a root, and you find A. So there is a process, okay? 276 miles. So what do we have? We have all sides and one angle. So we have all sides, 276 miles. B is 330, C is 55, and we want to find angle B. So since we want to find angle B, opposite angle B, 330 squared, opposite angle B, 330 squared equals this side squared plus this side squared. So 276 squared plus 55 squared minus 2 times 276 times 55 cosine B. To put this into a calculator, cosine B gives you a number negative 0.978, and B is the cosine inverse of this number. So the inverse function gives you B equals 168. What is the answer to the question? 180 minus B, 12 degrees. 180 minus B, 12 degrees. I hope it's clear to everybody. What new average speed is needed to keep the total time of the trip at 90 minutes? Well, if we want total to be 90 minutes, we've already gone for 15 minutes. So what is left? 90 minus 15 minutes. That is 75 minutes. And 75 minutes, it's 1.25 hours. D equals RT, R equals D over T, and the distance is A over T. This is the distance we want to cover, right? If we divide it by T, how much time do we have left? 1.25. So divide the value of A by 1.25, and that tells us we have to be going almost 221 miles per hour, 220.8 miles per hour to make sure that we make it over the course of total of 90 minutes. So that's the speed we need to do. So if we add a little bit, 220, we change it to 221, almost 220.8, we make it. A radio tower 500 feet high is located on a side of a hill with an inclination to the horizontal of 5 degrees. So it's 5-degree inclination. How long should two guy wires be if they are to connect to the top of the tower and be secured at 2 points 100 feet? Each one is 100 feet away, directly above and directly below the base of the tower. So this is 500 feet. We are going to connect two guy wires. Each one goes 100 feet away. And this has an inclination of 5 degrees. Just to make sure we understand what's going on, we are going to do this drawing without this tower so we understand what's going on here. So this distance, we want to call it X because we need to find them. How long should two be? One of them is X, one of them is Y. This is 100, this is 100, and this is 500. And this angle is 5 degrees. If we draw this, and we know this is 5 degrees, this must be 85 degrees. So we make this larger so it becomes easier to see. So this angle is 5 degrees, everybody. Then this angle must be 90 minus 5, 90 minus 5. So this must be 85 degrees. So this is 85 degrees, everybody. And now, if this is 85 degrees, look at this one. What is this angle? This angle with 85 must add up to 180. So I hope you realize this one, again, plus 85 must be 180. So this one must be 95 degrees. And if this is 95 degrees, of course, this one has to also be 85 degrees. So I hope you see what I'm talking about. This is basic. First of all, these two lines says 85 degrees. Secondly, you can say they do add up to 180. So this is 85 degrees. So what we have is we have all the angles that we want. So Let me use, okay. If you look at this one, now you have this side is 100, this side is 500 feet. You have this angle of 85 degrees, and you want x, so you say x squared is 500 squared plus 100 squared minus 2 times the product of these two times the cosine of the included angle, 85 degrees. So one more time. In this one, x squared is one side squared, 500 squared, plus the other side squared, 100 squared, minus 2 times the product of the two sides, minus 2 times 500 times 100, and the cosine of the included angle, which is 85 degrees. If it's hard to see that, let me just erase my work and do this again in the following manner. So this one is 85 degrees. And this is the triangle we are looking at. So we just plug in and we find the x. I'm leaving it for you to, just plug in it's into a calculator. And you get over 500, 501.28 feet. We do exactly the same thing for the other one, everybody. Let me use a different color now. Let me use the blue one. So this one, everybody, we have this side 100 feet, this side 500 feet. The included angle, and let me use a different color for that as well. The included angle here, 95 degrees. So y squared is 500 squared plus 100 squared minus 2 times the 2 times 500 times 100 times cosine of 95 degrees. And you put it into a calculator and you find the y value at 518.38 feet. As you can see, this is a tad longer as it is supposed to be because of the inclination. Draw and solve the triangle A is 8, B is 3, and C is 6. This, you just do the drawing and it may not be necessarily to scale, but we are using SSS, okay, cosine law. So here's A, here's B, here's C, okay. A is 8, opposite the largest angle, okay. B is 3 and C is 6, okay. Since we have all sides, we have to pick up one of the angles, and cosine A is B squared plus C squared minus A squared over 2BC. And so this one is B squared, 3 squared, or 9, C squared, 6 squared, or 36, minus A squared, or 64, over 2 times B times C, 2 times 3 times 6. Just plug in. I'm just plugging in. I get negative 19 over 36. A becomes cosine inverse of this number. I put it into a calculator, 121.86 degrees. We have angle A. Let's do the same thing for angle B now. So cosine B is A squared plus C squared minus B squared over 2AC. So A squared is 64, C squared is 36, minus B squared is 9 over 2 times 8 times 6. You work it out. Over the 8 times 2, 96. 91 over 96, so B is the cosine inverse of that. Resulting in 18.57 degrees when you put it into a calculator. So what happens is we got everything. We add these two and we subtract it from 180. So this is one, if you 120, 140, the other one, you can find it as about roughly about 40 degrees, just roughly, because they add up to 180 and everything is here. I'll show you one more time. So this is 180 minus the sum of 121.86 and 18.57. That's what gives us 39.75 degrees, and we have all of the above. Find the area of a triangle given three sides. Find the area of a triangle with sides of length 3, 4, and 5 centimeters. We're going to use what's called Heron's formula, finding area of a triangle given all three sides. First of all, A plus B plus C divided by 2 is used as S. This is called semi-perimeter. Terminology for this one is semi. Perimeter S. That's the terminology. And the area is S times S minus A times S minus B times S minus C. So let's find S. A plus B plus C divided by 2, 3 plus 4 plus 5 divided by 2. 7 and 5, 12 divided by 2. And the answer is 6. We are going to put it into the formula of S times S minus A times S minus B times S minus C. So let's do that. We are going to replace the S with 6 and ABC with ABC here, 3, 4, 5. So this is 3, this is 2, this is 1. Their product is 36. And the answer is 6 centimeters squared. I want to quickly show you something. Of course, I have the proof of this at the end. As far as Heron's formula, the proof is very long. But just to see how that works, I picked those numbers on purpose. I want to show you some. 3 squared plus 4 squared is 5 squared because this is 9, this is 16, this is 25, which means it must be a right triangle. It's the reverse process of the Pythagorean theorem. And so you're dealing with a right triangle. with 3, 4, 5. As you know, the area is 1/2 base times the height. And in a right triangle, the base and the height are the two legs. Just ignore the hypotenuse. So this one is 90 degrees. So 1/2 times 3 times 4, and that's the same answer. So you see that works out.